Hello, my dear students. Today we are going to discuss the continuation of quantum mechanics. Separation of variable. Separation of variables. Separation of variables. This is a continuation of particle in three-dimensional box. actually, particle in three-dimensional box represented by the equation del square psi plus 8 pi square m by h square e psi is equal to 0. Students, this is the equation for inside the box. Yesterday I said you outside the box psi is equal to 0. Therefore, this is the inside the box. Here del square, the Laplacian operator del square is equal to dou square by dou x square plus dou square by dou y square plus dou square by dou z square. What is this meaning? In this operator, the function is varying with the x, y and z simultaneously. Therefore, psi is varying with, suppose you put the psi here, the psi will be varying with x, y, z simultaneously. This is a very difficult situation. Normally our graph, suppose a normal graph, we have an x-axis and y-axis. What is this? It is dy by dx. Y is varying with respect to x. Only one variable, that is y. Y is varying with respect to x. But in this case, psi is varying with respect to x, psi is varying with respect to y, and psi is varying with respect to z. Therefore, such a situation, psi varying with respect to x, y and z cannot be represented by a simple graph, because it will have three-dimensional graphs. Our graph is two-dimensional. It will be a three-dimensional graph. Therefore, normal mathematics would not help you to solve a Schrödinger equation with these three variables. Therefore, we have to separate the variables into two-dimensional way, into single variables. That is called separation of variable. Therefore, separation of variable is a method to separate each variables into simple equation to get simple equation. Simple equation nothing but one-dimensional equation. Again, we are splitting three-dimensional equation to one-dimensional equation for our convenience of treatment. We can see how to do that. We are assuming psi is a function of x, y and z. Psi has three components: x component, y component and z components. What is this x here? X is a wave function. X is the wave function which depends on which depends on x is a wave function which depends on x axis, x component. We can say x axis for simply x axis. X is the wave function. This capital X is wave function. Psi x, suppose psi x. X is the wave function that depends upon that varying with the x component only. That vary with x axis only. For simply saying. Similarly, capital letter Y is a wave function which depends upon y component only. Y component only. Okay. Similarly, Z, capital letter Z is a wave function. Remember, wave function. Z is the wave function. Small letter z is the component by which capital letter Z is varying. Capital letter Z is varying. Therefore, we assume this psi is composed of three different wave functions, that is x, y, z. Each are varying with respect to corresponding components only. Okay, yes. Now similarly we assume another chain E. This E is we are talking about this E. This E is a total energy. Total energy, obviously it is total energy of the particle. This E also has three components, that is Ex plus Ey plus Ez. Therefore, total energy has a component along the x direction, y direction, and z direction. Similarly, our wave function psi has the component in x direction, y direction, and z directions. Now, suppose we write dou square psi by dou x square. What is the mathematically? We are deriving psi with respect to x component. But we have already said that our psi has three components, x component, y component, and z component. Therefore, the x, y component and z component wave function of this psi will be a constant because we are deriving only with the smaller x. Therefore, we will get dou x square by dou x square. Okay, dou square x by dou x square. What is x? Is a wave function of psi along x component. Similarly, when you derive dou psi by dou y square, the x component and z components will be constant and only the derivation happens for y component. Okay. Similarly, you derive dou psi by dou z square. The x component and y component of that wave functions are constant. Only the derivations happens in the case of z component of the wave function, dou z square. You are getting like this. Okay. Now, therefore, we can summarize like this. Our del square is nothing but now, del square psi is nothing but now summation of these three. Del square psi. What is del square psi? Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square is equal to yz dou square x by dou x square plus xz dou square y by dou y square plus xy dou square z by dou z square. Therefore, our Schrödinger equation, three-dimensional equation, del square psi plus 8 pi square m by h square e is equal to 0. This equation will be resolved like this. y z, I'm copying this, dou square x by dou x square plus xz dou square y by dou y square plus xy dou square z by dou z square plus, now add this 8 pi square 8 pi square m by h square e is equal to 0. Don't forget this e is equal to ex plus ey plus ez. I will use this term whenever required. Okay, don't forget. This e is equal to sum of these three. Anyway, this is our equation number 1. Name it equation number 1. Okay, we resolved. Yes. Now, please divide. Let us divide. Divide equation 1 with 1 by x, what capital letter x. What is x? Wave function along the x component. Y, z, all are capital letters. Opposite of this. Okay. H square by 8 pi square m. Divide equation number 1, every part of equation number 1 with this term. Okay, let us divide. Let us see what happens. Divide equation number 1 with this. Okay, now what you will get? See, we are going to divide this equation with this term. Now, this is our equation number 1. Okay, this is our equation number 1. Therefore, when you divide, this is our term x y z dou square x minus by dou x square. That term is going to divide with this term. Look at here, 1 by x y z h square by 8 pi square. Therefore, this y z and this y z will be cancelled. Fine. Therefore, what is remaining? 1 by x. This x. Then this term dou square x by dou x square. Then this term h square 8 pi square m. H plus. Now in this case xz and xz cancelled. Therefore, what is remaining? 1 by y. Dou square y by dou y square h square 8 pi square plus. Okay. Now this is simple. 1 by z dou square z by dou z square h square 8 pi square m. Now what happened to this case? What happened to this case? Listen me, what happened to this case? Here you have 8 pi square m by h square. 8 pi square m by h square. Therefore, tell me, what happened to that term? Therefore, that will be completely cancelled. Therefore, this term will be complete. Therefore, you will get 1 by look at we are going to divide. Therefore, that term will be completely cancelled and x y z. You will get like this. Okay, is equal to 0. Ex ey ez. Yes. Just okay. Yes. Now this term has been resolved as ex plus ey plus ez. Therefore, our equation will be like this: 1 by x dou square x by dou x square h square 8 pi square m plus 1 by dou square y by dou y square h square 8 pi square m plus 1 by z dou square z by dou z square h square, this is capital letter, this is small letter, 8 pi square m plus ex plus ey plus ez is equal to 0. Now our equation is entirely segregated into completely x terms, y terms and z terms. Now we can take the x terms alone. This is our x terms. Okay. If you take the x terms alone, you will get an equation like this. 1 by x dou square x by dou x square h square 8 pi square m plus ex is equal to 0. Okay. Now what is this? You just rearrange this. Dou square x, capital letter x, dou x square is equal to minus, you bring all this into that side, therefore 8 pi square m by h square x ex. What happened? You bring all this minus e, you bring this other side, therefore 8 pi square m divided by h square, this x will be at the numerator. Okay. Now you bring it back, you will get it like this. Dou square x by dou x square plus 8 pi square m by h square x e x is equal to 0. Do you see any connection this with the one-dimensional equation? Can you see any? Yes, you can see. What is this? This is wave function. Wave function along the x direction. Wave function along the x direction. Therefore, this is equation like this. Dou square psi x. Wave function along the x direction. Dou x square plus 8 pi square m by h square psi x ex is equal to 0. This is the equation for one particle in x direction, one-dimensional x dimensional particle in x dimension. It is a Schrödinger equation for particle in x dimensional. Dou square psi x by dou x square plus 8 pi square m by h square psi x. But psi, instead of psi x, please use capital letter x. It is the equation for Schrödinger equation for particle in x dimensional. Similarly, Schrödinger equation for particle in y dimensional is dou square psi by dou y square plus 8 pi square m by h square y e y is equal to 0. This is the Schrödinger equation for particle in y dimensional. Okay. Similarly, Schrödinger equation for particle in z dimensional. Dou square z by dou z square plus 8 pi square m by h square z ez is equal to 0. Don't forget this capital Z means here wave function of particle along z direction, and this is the equation for particle in z dimension. Therefore, you got three equations. Equation number 3, equation number 2 and equation number 1. Each equation have only one variable. What is a variable here? wave function, variation of wave function of x with x only, energy also varying with x only, and wave function also varying with x only. You got a quadratic equation with the single variables. That's very important in mathematics. Here wave function is varying with y only. Wave function is variable with respect to y only. Energy also variable with respect to y only. Here energy is variable with z only. Wave function is variable with z only. Therefore, this separation helps you to get a quadratic equation. Second order quadratic equation with a single variable. Therefore, solution of these equations are quite easy.